All right, thank you everyone for joining. Welcome to Forge Partner Talks Digital Twins. I'm Sanjana Chen. I'm the Developer Marketing Manager on the Forge marketing team. I've been at Autodesk and on the Forge team for about 2.5 years now. You probably know me better as the @Autodesk Forge handle on social media. You may have noticed that your video and microphone are disabled. I will be guiding the question and answer portion at the end of today's partner talk. So please feel free to type any questions you want into the Q&A box. We'll address as many as we can in the last 15 minutes, but if we can't get to your question, we'll follow up with you after the webinar if you include your name. And we will be recording this session, so we'll make it available to you as soon as we can.
Great. Thank you, Sanjana. So good morning, good afternoon. Thank you again for joining us today. I'm really excited to kick off the May webinar series, and I'll start with a quick introduction of myself. My name is Emily Sherbensky. I started my career as a business consultant, but joined Autodesk about 5 years ago and haven't looked back. I now lead the Forge marketing team, and I'm very excited to talk to some of our top partners over the next few weeks about a variety of really interesting topics. So as Sanjana mentioned, please submit questions throughout the session, and our panelists will answer your questions at the end. But with that, let's jump into today's topic, which is digital twins. So I'd like to start by introducing our panelists. The first up is Torbjørn Grimstad, who's joining us from Moicon in Norway. Moicon's been a Forge partner for many years now and recently joined our Forge Systems Integrator program. So Torbjørn, would you like to introduce yourself and tell us what your role is at Moicon and a little bit about what your company does?
Yeah, thank you very much, Emily. Hello all, I hope you're all doing well all around the world. So my name is Torbjørn and I'm tuning in from Norway, which is where Moicon is based out of. Today's topic is digital twin, and I'm going to be showing you later a demo showing how Moicon is approaching this concept of digital twin. We are working with this concept towards manufacturing industry, and we're very much focusing on the visual presentation of data. And we're obviously using the Forge viewer, and I'm very excited and happy to be able to share with you our approach later in this call. Thank you so much for attending.
Thanks, Torbjørn. All right, so next we have Andrew Arnold. He's joining us from VueOps, which is a subsidiary of DPR. And you may have seen them at DevCon Las Vegas last year if you attended. Not only were they a partner on the floor, but DPR's Eric Lamb took the keynote stage and shared a bit about what the company was doing, including their work with VueOps. So Andrew, would you like to introduce yourself, your role, and VueOps?
Yeah, thank you. Hello, everyone. It's a pleasure to join you today in this webinar. My name is Andrew Arnold, and I'm head of product for VueOps. As noted, we're a subsidiary of DPR Construction. DPR is, was an early innovator in digital transformation for the building industries. And our investments typically focus on operational improvements to enhance project delivery. And so we're a member of several subsidiaries of DPR at this point, including vConstruct, Digital Building Systems, and EIG. And our mission really at VueOps is to solve the problems of construction information and data turnover to building operations. So today I'll be showing a demonstration of our product as well. Thank you.
Great, thanks. All right, so last but not least, we have Alban Alev, who's joining us from Capgemini. Capgemini may be a name familiar to many of you. They joined our Forge SI program last year. Alban, would you like to introduce yourself and Capgemini?
Yeah, thank you, Emily. Good morning and good afternoon to everybody around the world. Very pleased to participate to this Forge Partner Talks. Basically, you know, Capgemini is a consulting and integration company, and I'm leading in that company the smart digital twin offering, which is basically the digital twin for smart buildings, smart assets, and smart cities. So I will be very happy to show you the realization we have done with some customers as well as some demos today.
Great, thank you. Okay, so let's stick with Alban for now. Do you want to jump in and tell us a little bit more about the solution that Capgemini has built called Reflect-IoD?
Yes, so indeed we come from a sound experience in digital integration that we have done historically over 15 years in the sectors of the industry. First of all, this has started with the nuclear industry, oil and gas industries, and then facilities such as energy utilities, and then it generalized to ASC as well as manufacturing. And basically, as a NIS company, integration system company, we have done a lot of integration projects to assemble the data describing the assets among the existing systems, such as the CAD systems, the CMMS system, the GIS system, the document management systems. And obviously, each of those hold some part of the truth, some part of the information of the digital twin, but not all. And none of them was capable by its own to hold all the information describing the asset and therefore to be the unique single source of truth and be the digital twin. So we came to a point in 2014 that the digital twin should be a system by its own with the main duty to federate the data that comes from the other systems. So federating the data from the 3D BIM CAD system, from the operating and maintenance system, or the geographical information system in a single platform. And we have started to create in 2014 our first generation of platform. And indeed, when we saw it was in 2017, by the way, the rising of forge technology, we just felt in love because it was solving a lot of issues that we had in order to be, first of all, agnostic towards the data formats, and you would recognize here the derivative API powerful that we have met, but also the large model viewer in terms of showing the result very seamlessly, and also with other APIs that we have then looked around, such as generative design and design automation. So based on that, we have created the Reflect-IoD digital twin with a particular focus on asset operations, which is in the life cycle of the asset after the design and bid for the operations, where there is a particular challenge around many systems that create data that describe the asset, and that needs to be federated in order to create a 360 view of the asset for better efficiency in the maintenance and operation, the lifespan of the asset, as well as the people and assets, safety and security.
That's great. Do you have perhaps a demo or a customer story that you can share to shed a little bit more light on how this is actually implemented?
Yeah, sure. So I will start with a demo. So let me know when you see my screen.
Well, yep, we can see your screen.
Yep. So basically here I will connect to Reflect-IoD using a profile that has access to different projects, and indeed those are our demonstration projects according to the sectors. And the first use case we'd like to show is the use case where I am a facility manager that has to manage all Capgemini buildings and offices around the world. So I will enter this project and I would select, for example, the first building, which is the Paris region building, in which normally I stand, but obviously not today. So here you would recognize the large model viewer from Autodesk Forge. You know all the capabilities we have here to go into subjective and first-person view. I can shade some walls and some object of the model. I can enter the rooms. I can make measurements. But I have also the possibility as a facility manager to go at the patrimony scale and see overall the map, this building and other buildings. So here I would select my building on the map, and I would access to the famous 360 view of that asset, of that thing that I have clicked on, which is a building. And I would see then the dimensions of information for this particular building. The dimension being the attributes that you can see here in the first tab, the relationships, the document, and the last one being the IoTs. So here we have some pictures, we have also some videos, and we have some videos and some IoT. So typically here we are connected to the building management system that delivers and highlights the occupation rate of the building when there is people in there. So if I zoom out, I would see another building that is nearby, and I can update my 360 view, showing some details. And the reason why it's red here is because we have received a notification saying that one of the equipment is in default, and this equipment is an elevator. So selecting this notification, we switch automatically to the 360 view of this elevator, having all the details on this elevator. Again, attribute, relationship, documentation, and IoT values. So here, for example, I would be able to see what is the right procedure, what are the spare parts I should have to put in place and to get there, and take my decision in a best awareness way. Obviously, from there, either I can trigger a work order from Reflect-IoD, or I can switch to my preferred CMMS system, such as IBM Maximo, which is what we have demonstrated. I will show a second use case, which is more an industrial scenario, where we don't have CAD 3D. So what we will work with is a laser scan. So this is indeed a pilot that we have done with the nuclear facility technical room. And indeed, here as a facility manager, if I have to intervene on this particular tank, which is at the bottom of the room, same story, I can select the object and have access to its 360 view. So here I would select the tank, open its 360 view, and access attributes, relationships, documentation, and IoT. I can also interact with the environment. For example, if I have to bring tools, I have to measure if my tools would pass on this particular stairs and see if I have enough space. Yes, there is 86 centimeters, it will be enough. If I had to intervene on the pipelines that we see at the right, it will be the same. I can measure on the laser scan the diameter. I will just speed up a bit. So another way to enter the digital twin is to use a tag, you know, the ID of a particular equipment. So I can search, find the tag, and zoom on it then. Here we can see that we have a mixed 3D model where we have laser scan plus CAD 3D information. And on this particular valve, I can have access to its relationship. So for example, all the work orders we have done on the valve, and see that the last work order we have done was to change its valve seal, and we know who has done it with what result.
That's
Again,
great.
we can have access to, yeah.
I was going to say, it's obviously pretty apparent how this helps with efficiency of maintenance and operations for a customer. Are there other benefits to highlight for customers implementing the solution?
Yeah, indeed, it's first of all, and I think that we will share that over the session. Digital twin is firstly an object to collaborate on. So to make all the different disciplines working with the same reference of data, and this is the first impact and the first benefit that we create. Then obviously all the benefits you can get from there is operational efficiency, as well as safety for the operators, because you see here we can prepare to the intervention and being better prepared to do it, explaining the staff to less hazards.
Great. All right, this is awesome. I'm sure we're going to dig more into it, but I want to make sure we can all share a little bit. So can we switch gears and move to Andrew? And Andrew, can you share a little bit more about VueOps and the solution that you guys have built?
Certainly. Just give me a moment here to share my slideshow.
Absolutely.
So, you know, similarly to Capgemini, VueOps provides a digital twin for integrated information. I'll go into that in a little bit. It's a cloud-based system. Also includes a general contractor warranty ticketing system And we get both kind of that's useful to the owner in terms of having a shared list of warranty items during the year following turnover of the building. And in addition, it gives the builder analytics in terms of understanding quality issues that occur during installation of products into the building. So it serves kind of both the owner and the general contractor. Also, VueOps includes a cloud-based document storage environment as well. This is a fully coordinated model for a healthcare facility that DPR delivered for UCSF Health, the Mission Bay complex in San Francisco. They delivered it in 2015. And it's an example of a fully coordinated model coming out of a sophisticated design and construction project, fully coordinated in terms of design and also installation of all the systems in the building and the skin and all of that. And in most cases, this is where facility data goes to die, fundamentally, in most projects, because the industry really is just now beginning to appreciate the value of all the knowledge that's developed during design and construction. And then owners are just now beginning to demand that we turn over the data as well as the documents and the models and integrate it all together into a unified presentation for facility engineers and managers to support them in their work. So luckily for us, due to the leadership of both the capital projects group at UCSF and also the facility engineering group at UCSF, we had the opportunity to deliver data into their work order system. It was also IBM Maximo. And we learned a lot about the process of doing that, the work it takes to actually help the owner define their requirements properly so we can get the data out and actually get a kind of an operating system for the building up and running on day one of occupancy, as opposed to waiting months and months and years to move that information into their systems. DPR and general contractors in general deal a lot with kind of this tension between capital expense and operating expense, and working with the owner during design to help them make selection of products and systems in their building that will benefit them over the operating life cycle of the building. And we really see this notion of turning over a digital representation or a digital twin to the owner, as well as the physical building, as critical to helping the owner realize the life cycle benefits of all the knowledge that's developed during design and construction. So we deal with that tension a lot. We have a lot of expertise about how the models are actually put together in the first place, how the data is developed in the first place, and then how it needs to be transformed so that it's useful for the owner. In fact, at UCSF, we learned that, of all the data we turned over, they really only need about 5 to 10% of the information developed by the design and construction team. And in addition, the way project teams typically organize the information for construction is different than the way the owner needs to see it. And so the owner needs to see it in terms of the systems in their building, the equipment that are members of those systems, and the locations in the building. And so re-indexing the information, kind of reconfiguring it, re-indexing it is a whole kind of set of tasks and activities. Some of it's automated, and some of it, frankly, is kind of blood, sweat, and tears these days still, supported by services work. And so that's our expertise. That's what we do. And I'm happy to show you a demonstration of kind of the building information model visualization part of VueOps. We have a user interface that starts again with kind of the portfolio view of facilities and lets you dive down and find documents, lets you find assets, lets you find systems without models at all. And then we make use of the Forge technology, the Forge viewer and Forge APIs to really to support the workflows of the facility engineer using the building. So this is a video of how the system works.
Awesome.
Let me this thing is running, just a second. So here we've got a building, and we're looking through the Forge viewer. Let's say an engineer gets a cold call about a room in a building, Delta room. Using VueOps, they're able to, I'll kind of pause the demo here. They're able to navigate directly to the room simply by typing in the room name in the VueOps. You can see in the top left, the room name there in the top left. There's a slicer built into the user interface, so then he can then go slice the building. He doesn't have to know anything about VimmerCAD to do this. Oops, sorry, I messed it up. Identifies let me start this over again. Maybe I won't pause it. Identifies a register, the diffuser in the room, and then using VueOps, because we support the relationships between members of a system, the facility engineer can then go trace back from the diffuser. You're about to see them slice down to the diffuser, select a diffuser, and then find the data about the diffuser, the documents about the diffuser, and also the relationships with other members of the system. There's the integrated document presentation there. And go back to the fan coil unit for that room. See the fan coil unit pull up its documents in terms of its O&M manual, its warranty information, etc. See the data about the fan coil unit, and then determine that they're going to have to shut it off in order to make a repair, and then wants to go find the electrical panel that services the fan coil unit to shut it off. And so we navigate directly to the electrical panel. Again, you can find its specs, and also, really importantly, understand the impacts of all the occupants in the building of shutting down that electrical panel. So that's a simple demonstration of the viewer portion of VueOps. There's a lot more to VueOps that, if I had more time, I'd go into. But I want to, at this point in time, wanted to kind of demonstrate kind of the reification or the demonstration of a digital twin of the building, starting with the model, starting with the 3D representation, tying in kind of the first level of BIM is, first level of digital twin really is a 3D representation. Second level is tying in historical data from work order systems, etc. The third level then would be kind of tying in real-time sensors from the sensors in the building, kind of using IoT hub technology. And moving on from there to bringing in external data from the world, like maybe weather reports, etc., so you can understand the impacts on building performance. And then really the last level of a digital twin would be to make it self-operating, give it the intelligence for the system itself to make changes in terms of how it's operating. And that's the mission we're on at VueOps, is to kind of walk through those levels of the digital twin and deliver them as we go. And presently, and honestly, the main focus is on organizing the design and construction data so that it's high quality information that moves into the owner's systems. Just wanted to mention as well that VueOps does integrate with computerized maintenance management systems, because we're interested in tying all that building information into the historical work order system, historical data that's available through work order systems. And this is an example of us integrating as well with IBM Maximo.
Great. Andrew, I love that you touched a little bit on what the future looks like for VueOps as well, and also touched a little bit on the work that you did for a specific customer, UCSF Health. Do you have any metrics or anecdotes about how UCSF benefited from implementing VueOps?
Well, they're benefiting in many, many ways. I think number one, and I'm in agreement with the gentleman from Capgemini, number one is just pulling all the information together and getting it integrated.
Yeah.
That's benefit one, so that people spend less time looking for information. Number two, in a mission critical facility like a hospital, uptime in the facility is critically important. So, for example, our friends at UCSF, soon after, in the first year after the building was turned over, they had a leak on the first floor of the hospital where there was a leak coming down a vertical, 2-hour rated vertical shaft in the hospital, and it was flooding the cafeteria area in the building. For the first time ever, instead of having their engineers start poking holes in the shaft all the way up through the 7 floors of the building to try to find the control valve to shut off the problem, they went to the model. They were able to trace back from the cafeteria up through the vertical shaft. They found the control valve, and they shut it down and they contained the problem within 45 minutes.
Wow. And usually how long does it take?
Pardon me? Well, this incident occurred at about midnight on a Sunday night. And it's just so happened the access to the control valve was through an operating room, and the revenue generated by an operating room is on the order of $10,000 per minute. So it's meaningful for the hospital. And so they had the whole thing contained and repaired by 7 a.m. the next morning.
That's awesome.
So that's a incident response use case where the investment in kind of this paying attention to the operating, the OpEx side of the house and their needs over the life cycle of the facility is really quite critical. And so that's I think that's a great anecdote in terms of an incident response.
I agree. Thanks for sharing that. right,
Yeah.
Switching gears again, let's move over to Torbjørn. Can you share Moicon's digital twin solution?
Yeah, definitely will do. So, thank you. Can you confirm that you see my screen right now?
Yep.
Perfect. So I'll be showing you two demos, one featuring workflow and the second one real-life project. So before I jump into the actual demos, I would like to just give you a brief definition of how Moicon is looking at digital twin. So we like to split digital twin into its two parts and getting the two aspects of it. So we got a digital aspect and we got a twin aspect. So we like to focus on communication and simulation for the digital features. And then we look at the virtual representation of the physical asset and the 3D model when it comes to the twin. So here we're into the first demo. Moicon uses Forge to create digital twins of factories and other facilities by connecting 3D models, facility management information, and IoT data together in dynamic 3D representations of factory floor, like you can see one demo here. It's all in the browser. You can see I'm in my Chrome browser right now. Digital twin has many advantages, but one of them is that it can be nice to use both for the planning phase, as mentioned by the two earlier speakers, but also in the operational phase. So in this particular workflow, I will be showing you how we are relocating assets and applying process analysis to see whether there's room for any improvement in our layout. So what I will do now is I will move this part away because I would like to relocate it and see if there's a better fit for this. So I'm bringing in some assets from the other corner of the room and I'm applying some transitions to it. And I want to bring in two operators to be working on this particular cell. This is going to be an 8-hour shift that I would like to analyze. So I am now mapping out my process analysis, starting with my source, and then I'm adding in the processors that are going to be applied to the configuration, buffers, etc. And then I have a product in the very end. So to complete this configuration, what I do is I attach it together like this. And when I'm happy about the config, then I can start inputting different kind of metrics, like what kind of product do I want to simulate, how many sources do I want to output, how often do I expect things to break, etc. So now you can see that I'm playing my operation at 1x speed, speeding it up a little. So now I can see the algorithms are working in the background, and I'm able to see what kind of information it's giving us. So here there are some inefficiencies, some operations are breaking during the 8-hour shift, but it's being fixed. And I'm waiting for my 50 products to be completed to review the data. So here I can see efficiency. I see that the green lines here represent efficiency, the blue idle. So this one has potential. Here you can see the same, this processor. Buffers, they are always available. So maybe I could erase one buffer here actually. So the nice part about this is that in addition to the 3D model, you have this technology from Forge called design automation, which enables you to have synchronized your DVG files from the same floor. So here you can see the upper left being reflected in our DVG, which is synchronized parallel to the 3D file. And what I can do is I can download this. I have my PDF and my DVG from the solution, so I can open it up. And then I get my blocks directly translated from the 3D objects. So that could be a nice way to, let's say you want to prepare this layout in the actual environment. Maybe you want to plan ahead using the 2D layout. That's one way to do it. That concludes the first demo. So now I'm jumping into the real life project, which is related to our Norwegian Technology Catapult Center. The model in the background we did for the purpose of showing all its internal assets. So here we have the real life drone photo of the environment. So we made our own digital version. And this one holds a little different data than the previous demo. Here we have focused more on the IoT data concept. So I will be going to zoom into one room in particular here that has this information applied. Here you can see some small wooden houses, and those are moving around in production environment. So they would like to get some data out of these houses. So we applied a sensor dashboard, and here we have a lot of data connected to these houses going. Here you can see some streamlines. It's called spaghetti diagram. It's showcasing where equipment have been moving around. So it's better for you to analyze position. We can, of course, inspect assets like this extinguisher, or we can look into progress tracking, like in this example, where we are seeing houses are being mounted because they apply courses here where houses should be green when they are 100% completed. So with this progress tracking, it's just another tool set of what you can apply in regard of IoT visualizations in your model. So that concludes my second demo and my introduction. Thanks for your attention, and of course we'll be happy to answer any potential question if there's time for that at the end. Thank you. Thank you, Emily.
So, Torbjørn, I'd like to understand a little bit more. This is a really cool case study that you're bringing up. What were the customer needs when they came to you, and what benefits did they find from the solution? Can you dig into that a little bit more?
So this is actually a technology center. I know Autodesk has one of those, and a lot of other big companies has these tech centers. And the purpose of these centers is that manufacturing clients can enter this building and look at technology to apply on their factory floor when they're back home. So what they would like to feature here is a way to make processors efficient. So what you're doing is you are taking away manual processes and you are applying automation. And to do that, we are visualizing the data in 3D in an intuitive way, so that we very much think that user interface is key for the user experience. And when you have the user experience, then you have a tool that can be used by operators regardless of your technical knowledge. So the idea of this tech center is that people without technical knowledge can come in, test out real equipment like these houses, and then they can see data being reflected in digital solutions like our Forge-enabled solutions, so that they can get value out of what data in 3D can give them as operators on the floor.
Great. And you actually found that after you had been building your own digital twin solution, customers were reaching out to you for help integrating their own customized digital twin technology. Is that right? It's one of the reasons why you joined the Forge SI program?
Yeah. So we have been, of course, we are serving this product as a SaaS solution where you have these modules which are integrated in Moicon, but we are also customizing a lot of solutions for different SMEs, small and medium enterprises all around the world, and they have custom needs. And then we really use the Lego blocks that are available within Forge. You saw the sound automation, you see the viewer. There's so many techniques that we put together, and then we can help them apply a certain workflow with our experience that we got through being involved with Forge now for 2.5 years, and by applying a bunch of accelerators and university and getting this real deep knowledge into this good kind of technology that's available with Forge.
That's great. Thank you. All right, so I want to be conscious of time because I know that a bunch of great audience questions have come in, but I'd like to ask one more question around the challenges that all of our panelists found in the digital twin space so far. So starting with Andrew, what's the biggest challenge that you found in implementing digital twins, either building your own or helping a customer?
I'd say there's a couple. One is getting the project teams to understand that the goal line, if you will, the endpoint of a project is not simply delivery of the building, but delivery of the data formatted and organized in the way the owner needs it. Mm-hmm. And so for that, both the owners often need help in trying to communicate that to the project teams, and also project teams still need help in terms of understanding what those requirements are and executing on them. I'd say most project teams are really good at what they do, but they need to understand the requirements. And so helping them understand the requirements and then use the tools that help to deliver those requirements. So for example, Autodesk has lots of tools for getting data out of Revit and CAD and all those things, how to use those tools, but to format the data in the way that per the specs of the owner. That's one problem. Okay. And then the other is demonstrating to the owner that that 3D can help them. Okay. You go into a lot of owner organizations and they're still working with plan sets in hanging files with paper. And then they've moved from there to maybe getting digital files on CDs. And even though those files are on CDs and they end up in a file system someplace, finding that information is a challenge. And then what's kind of still completely overwhelming for many owners is dealing with change management. The moment buildings are occupied, owners start to change them. They're not static. And so keeping up with change management so that the data is current and trustable is another outstanding challenge for owners. And so, you know, I think there's, you know, we're on kind of the early part of the adoption curve for owners that are really interested in moving to more of a data-driven approach to managing their buildings.
Yeah.
And we're proving the benefits, and I think we're successfully proving the benefits. But it's a behavioral educational process in the owner world primarily.
That's great. And I saw everyone nodding. All the panelists were nodding when you're talking about kind of convincing the customers of the benefit of 3D and digital twins. So I'm curious, Alban, for you guys, is that something that you found you kind of had to convince customers of the value of digital twins, or are there other challenges as well that you've run into?
Yeah, indeed, I fully align with what Andrew just said. I mean, digital twin is a part of a global digital transformation, and indeed, it can be a very long way, and it's not obvious for an EPC or for an owner operator to see what is his path, and therefore, what we have seen so far is that the digital twin area is still maturing. Okay, it's not so mature to say so, and there are many opportunities to take advantage of it. One classical figure that we use is that we see that the opportunity in terms of savings in the operation can be up to 30% of the cost of operation. So when you think that for main assets, the cost of the total cost of ownership is split between 20% in design and build and 80% in operations. Well, gaining 80% on the operations represents 80% out of 30% out of 80, which is 24. So it means that the opportunity is to win 24% of the total cost of ownership, which is more than the cost of build. So basically, you have planned to get one hamburger, you could get two, you know?
Yeah.
This is the kind of opportunity. But there is no one-size-fits-all approach. And the challenge that we see in the different sectors and clients that we are dealing with is that there is a high sensibility of the benefits you can get from digital twin to the data quality you have. And obviously, the data is never the same between actors, projects, because the partnership are not the same for that project or another. And it's a challenge, it's complex to establish what are the good data to produce the good benefits. And for that, I think that what is very important prior to any technical solution finding on digital twin is to really challenge and establish what would be the good use cases to produce benefits in the real data context that you are knowing.
Yeah, that's great insight there. Torbjørn, do you have any more to add around kind of challenges and how you guys have approached them?
Yeah, so I'm definitely supporting what's already been said. So we break it down into two bullet points. It's the communication part. We look at the digital twin as a way to communicate data because there's a lot of data going on inside manufacturing and other facilities. The second one is the social aspect, the culture part, where we actually want to make digitalization less terrifying because, you know, the rise of the fourth revolution is happening and a lot of companies are moving towards digital production. But the culture is maybe a little skeptical towards how can this help them. So we work very much on user interface, very close to our clients to enable them to use our software to get the data in an easy manner. So we need to solve the intuitive aspect of it, and we need to work close to clients to be able to to know that they're comfortable with the solution. So it's really about technology and culture.
Great. All right. Well, that was great. And I could still keep asking you guys questions for a while, but I know that we've had a ton of questions coming in because I've been seeing them flow in. So I'd like to spend some time digging into those. So Sanjana, can you tell us what's on our audience's mind? What questions do they have for our panelists?
Yeah, again, a lot of great questions did come in. We'll try to get to as many as we can. And sorry if we can't get to them all, but we will try to follow up with you if you did include your name. So this is a really great one. What challenges did Forge solve that other services could not?
Anyone that wants to jump in?
Well, it's critical. You know, from a product development perspective, Forge provides a platform for model visualization, number one. So that really, really decreases the cost and time to market for a value add vendor like VueOps. So we don't have to worry about that. Forge is also progressing in terms of integrated data across all those applications in the BIM 360 platform, and that's all available through Forge APIs. So the problems of collecting data are being tackled by Autodesk and Forge. Forge also solves the problems of really also developing a queryable system for the data. So it really reduces our cost of bringing these specialized products to market and solving, I think one of the panelists here talked about there's not one size fits all. That's really true. And so for different kind of building types and customer types, there'll be different needs and different levels of representation of the digital twin. You know, if you want to get into building analytics and autonomous systems that's kind of self-managed, you need a much more detailed representation of the equipment in the buildings so you can actually understand the thermodynamics of what's going on in these systems, for example, in an air handling system. So Forge provides a foundation, and then partners to Forge can do this specialization and do it in a way where it's not prohibitive in terms of cost of bringing these solutions to market. So we have a great debt of gratitude for the platform that Forge is providing to this ecosystem of companies that are building on top of it.
Cool. We can go to the next question, Sanjana, unless someone has something burning to add.
Sure.
Yeah, maybe I would add on this question that from the development perspective, Forge, because as I told you, I've worked with other technology before Forge, so we could compare the benefits to our teams in terms of business value to our customers. And indeed, Forge has solved most of the technical issues in which you don't want to spend time. And basically, it has enabled to go very fast to business value to our customers. And indeed, working on their algorithm, working on their business challenges, rather than working on showing 3D on a laptop or showing 3D on a tablet. You know, so for us, the definitive benefit of Forge is that it has enabled us to work on the business value.
Okay. There are a few different questions about data standards coming in. One, how do you manage different data standards coming into one federated environment? Something kind of connected and related to that is that a lot of companies probably already have their own data standards in place, and how do those fit within your digital twin solutions?
Yes, this is a tricky one, no? So, okay, we are talking about digital twin, and I think that everybody has understood that the visible part of it, which is the 3D model, is the easy part. Okay, the complex part is all the data and the data standards and the data model that is underlying those beautiful visualizations. And in that space, again, the reality is complex because according to various industries, there exist some standards. So if you work in nuclear, you would find some data standard, in oil and gas, some other standards, in AEC, some standards, in rail, some other standards. And indeed, each time that you face reality, you can see that from the data perspective, there is a need to be extremely flexible towards those standards, because one company would need to specialize the standard, and even within this company for such region, they would need to adapt it to the region, and even in that region, they would need to adapt it for this particular project. So indeed, digital twin is talking a lot of data federation and also data model flexibility. So what we generally say to as an entry point to the data is that digital twin should first let the data in as it is. So the digital twin should always accept the data as it is, and then expose it to what have to be then fixed on the data. Because you can't just assume that the data would come in the way you would expect it to come.
That's a good answer.
If I could add to that just a little bit, or you want to move on to the next question?
Please,
Yeah.
please do.
I agree, and at VueOps we have a services group that's dedicated to helping owners really define those requirements down to the schema level, down to the data definition level. And what we do, and we also have this issue of standards in the industry. So there's IFC standards, there's COBE standards. Most of these standards have done a good job of defining kind of a structured schema, so that you can pass the model around, pass the 3D geometry around. So we know, for example, the category of doors. So we know the category of fan coil units, right? And we know the basic properties to describe them geometrically. But really, none of these standards get down to really what do you call, what's the label you use to define a door? Single panel door versus a rolling door versus, down at the level of the names of things and the names of the attributes for those things, owners need assistance to come up with their own corporate standards. So we have a team, services team that does that. And we have a artifact we call a facility data specification, which really extends the kind of requirements definition that you typically get out of a capital project down to the owners of the FM organization. So we work with them with that, and then we do find a lot of variation across owners and across their buildings. And so similarly to Capgemini, we're going to be adopting a federated approach using ML and AI to kind of resolve these schemas, the differences between these schemas across buildings and across sites. And kind of that's our approach, that the standards do end up getting specialized a lot. And we're relying on kind of advanced technologies to unify them across buildings, but we're not really trying to take a top-down approach because people want to get stuff done, and typically they start with one building at a time and prove value. So while we pay attention to kind of these standards organizations and try to adopt them when we can, we also have to take into account this high level of variation at the implementation level. Thanks.
We have time for a few more.
Yeah.
Do facility owners tend to know what they want, or do you have to guide them into cloud-based solutions?
Yeah, I could go ahead to explain our approach. So when we approach a facility owner or manager, then we map out, we make a roadmap, and we look into what kind of facilities or equipments are vital for their success, what's gaining them bigger value with digitalization. So usually they are aware of what kind of processes that are granting revenue and where they would like to decrease downtime, etc. So we're very much focused on those areas as the setup to get this low entry into digitalization. So let's say you have 3-4 equipments that you want to bring in data from. Of course, as earlier mentioned, you need to be flexible in regard to standard, but you have to look into that specific source and then retract the data So the building owner, they tend to have one idea of it, and then we're working together with them on the floor with our team that are coming from the industry with their experience, and together building this solution. Parallel to that, they're getting the 3D model, and they can actually start seeing that I can use this for different kind of documentation systems, etc. So at the end of the project, they have applied more information to the digital twin than what they had foresaw when we initially entered the process. So they're seeing that there are lots of more potential that they initially was aware of our experience when we enter our partners and customers.
Anything to add? Recap or review?
Just that, you know, owners often know what they want conceptually. You know, they say, give us the data. And then it's an education process to describe how to get the data at the quality level that they need it. And so I've already described a few times the serviceless group we have, et cetera. So I think it starts off, there's an education process that occurs. And then there's definitely an education process that occurs, and a commitment that needs to be made to get the data at the quality level that they need it, both in terms of normalization of the data across projects and the kind of data, et cetera, and then how they'll actually use it and prove benefit out of it. And so that's our experience. That's our honest experience there.
Great. All right, maybe one more question, Sanjana?
Sure. If you could improve one thing about our current Forge service, what would it be?
Ooh.
I'm sorry, can you repeat the question?
If you could improve one thing about the current Forge service that could help you build better solutions in the future, what would you pick?
I actually have one very specific request, if I'm allowed to.
Yeah.
So what I would really prefer is that we upgraded the 3JS version from the current R71 to 115. It has a lot of capabilities towards point cloud, for example, and visualization techniques. So that's the one thing that I'm currently thinking would be a really nice add to the existing package.
Okay. Andrew smiling. Smiling.
Oh, I know it's coming. It's a request that I know is in the queue. You know, right now to get the data out of Forge, there's kind of a bulk extraction process, and we really would love that query interface to query, you know, endpoints directly. You know, give me doors. You know, give me a wall, whatever it is. So a real query interface to the data as opposed to a bulk download and then parse. You know, all that management is kind of expensive and time consuming, and we know that's coming.
Great. Alban, do you have anything to add?
Yeah, indeed. In continuity of that, definitely the data storage
Yeah.
and not the document storage is a big leap that we are working on with your teams. Yeah.
Yeah, and I mean, these are great to hear. We're constantly taking feedback. You know, we're growing too with you guys as Forge continues to evolve and meet your needs. It's a constant cycle of feedback and improvement. So it's great to hear. So last quick question. Do you guys have any advice for people thinking about entering the digital twin space or implementing a digital twin solution? Parting advice, if you will.
I would say maybe with the past experience we have had on digital twin deployment, the thing is really, if you have not seen the data, you have seen nothing. So rush to the data and see what you have, and therefore you would know what you can do with this data or what you can improve on this data. But avoid building a business case upon a theoretical situation, and test the data as soon as you can. And for that, there exist many techniques, but we have seen in very different customer situations that testing the data could save years and months of investment, focusing on the right use cases that can deliver value.
Great.
I would say for, this is a phrase that came out of Autodesk, start with the end in mind. Start early if you're looking at a capital project. Start early and get involved very early and bake the requirements into the project delivery process. And then keep in mind that it's a journey, because it's, as I think many of us have shared today, it's kind of a social and cultural process of learning that the development of data is a kind of a journey, and start with well-defined business goals, and you will see benefits, but there needs to be some investment of effort at the front end to get your ducks in a row if you're an owner. And then, on the first project, it might be more expensive than on the second project, for example. And but the costs do come down. The costs do come down, and they become a very small incremental cost that's very well justified through business case analysis. So it's very bright future, but understand that it's a journey, and get involved early and go incrementally.
Great. Well, thank you. We're at time. So everyone knows this session was recorded, as we mentioned earlier. We'll be posting it. You can find the link on our Forge blog. And this was just the first in a series of May webinars we're hosting every Wednesday this month at the same time. So you can see the topics on the screen right now. We're going to be talking to some other great partners and exploring other great topics. So please join us if you are able. Next week, we'll be talking AR, VR with Insight VR and Puro CIE. So it should be a great session. Thank you again to all of our panelists for sharing the great work that they have done. And thanks to all of you, to the audience, for tuning in. Have a great rest of your day.
Thank you.